Hi, this is Ms. Park. This is a continuation of annuities present value and future value. Just going to do some examples with you on how to use the annuity formulas. So I'm going to cover up my solution and just talk you through it. Determine the future value. Okay, so it says on the day of the last deposit, so that's at the end of the term. Determine the future value of quarterly deposits of $1,000 over 10 years at 5.5% per annum compounded quarterly. There's a lot of language in this word, in this sentence. So let's ask, determine the future value on the day of the last deposit. So we know we're using a future value equation or formula. The question is it going to be future value of a compound interest investment or an annuity? But it says quarterly deposits, which means there's more than one, right? Quarterly means there's 4 every year. So you know right away that that's going to be an annuities question. Okay, and so that's what we're looking for. We're looking for multiple payments. So I'm going to write that here. That's what's going to tell you that it's an annuity. Okay, of $1,000 over 10 years, this is the interest rate. And it's compounded quarterly, so when we calculate our I, we're going to take this interest rate and divide it by 4. What is the total interest earned? Okay, so in order to figure out the total interest earned, we have to first answer the first part, which is what are these all going to be worth? What is the future value? So I'm going to just step you through my solution here. I'm just going to cover this as well. Okay, first things first is to write the formula and then also write down your variables. So it's future value, R, which is the amount of the regular payment, so how much you pay each time, your I, and your N. And once you put them all into the formula, you get this number, 5285606. So just like in the previous video, I'd like you to stop and try to put this number into your calculator and just make sure you get the same thing as me, because every calculator is different and we have to be careful with brackets. Okay, so that's going to be the future value of all of these investments, all of these payments. So now it says, what is the total interest earned? So here's the thing. They're putting in $1,000 for 10 years, 4 times a year. So that's 40 payments of $1,000, right? That's our N. So total payments is $40,000. That's, if they were taking from their pocket, they'd be taking $40,000 in their pocket, from their pocket. But all of those payments will work out to this much after all the interest. So the interest that they've earned is the difference. So they've actually earned, how much is this? Hold on a second. $12,856.06. Okay, so it's the ending amount of the annuity minus all the money that they put in from their pocket. That's how much interest they've earned. Okay, another example, this next one, how much must be deposited each month at 6% per annum compounded monthly for 3 years in order to have $10,000 on the day of the last deposit? Okay, I'm going to go through the solution. If you want to pause the video and think about it, please do. Okay, so we're going to start with the future value formula because they said they want to know, they want to have $10,000 at the end. Okay, so that's at the end. So that's how you know that it's going to be a future value question. And because they said each month, they're going to be deposited each month, you know that this is going to be multiple payments. So that's how you know it's annuity. Okay, so there's 2 things to know. Is it compound interest or annuity? Is it future value or present value? All right, and so here I'm going to write my variables. Okay, so I want to have this at the end. I want to know how much should be the regular payment. So I want to know R. The interest rate is 6% per year, but we have 12 compounding periods. And the N is 12 periods times 3 years. So put all that stuff in. And now I'm going to show you how I calculated my R. What I did was I put all this stuff in here, but then I needed to isolate the R. So do this whichever way makes sense to you. You just have to be careful with brackets in the calculator. I'm going to show you what I did. I multiplied both sides by the 0.06 over 12. And then I divided by that big bracket to get my R, and I got this. So that worked for me in my calculator. So you need to try and see what works in your calculator. Now, the second part of the question says, what is the total interest earned? So just like the previous question, if they're going to make 36 payments of 254.22, that means they're making this much in payments. They're putting this much from their pocket. But at the end, it's worth 10,000. So actually, they've made a little bit of money here. They've actually earned some interest. So the difference between what they've paid out and what it turns out to be worth at the end is the interest earned. So it's this. All right, let me do some examples of what's it called? Present value. Yeah, let's do some examples of present value. So I'll step through them again very quickly, but the point is that we're going to talk about what makes it a present value of an annuity question. How do you know from the question? So Donna plans to deposit a sum of money in an account which pays 9% compounded annually so that she can make 5 equal annual withdrawals of $500. How much should she deposit if the first withdrawal is 1 year later? So this part over here, the first deposit is 1 year later, ignore, because as I told you, with ordinary simple annuities, we're always making the payment at the end of the compounding period. So in this case, at the end of the year. So forget that part, it's not important. Okay, but the thing is, how much should she deposit now? How much should she deposit now? And she wants to take out $500 every year. So it's how much should she deposit? I'm going to put here now. Okay, so how do you know it's annuity and not compound interest? Because she's going to make 5 equal withdrawals. So this is multiple payments. Okay, it's happening more than once. She's going to take money out of the account. Okay, and how do you know that it's present value and not future value? It's because they're asking how much you should put in the account now. So this is like that retirement example. If she's putting money into the account now so that she can take money out of the account every year for the next 5 years. All right, so it's present value. We put in all our variables and we figure out the present value, how much she needs. Right? And if you look at it, notice five annual payments of $500, that's like $2,500 over the 5 years, right? But she only needs to put in this much to get $2,500 worth of payment. So she's actually making money in interest, right? And the interest that she's earning is $2,500 minus this. Actually, I'm going to put that here. So the interest earned is 5 payments of $500 that she's getting minus how much she's putting in. Okay, and whatever that works out to be. Second example. All right, so here we go. Here's a retirement example. So Mr. Harrison's life savings total $280,000. He wishes to use this money to purchase an annuity, earning interest at 12% compounded semi-annually, which will provide him with equal semi-annual payments for 20 years. Okay, so this is how you know it's multiple payments. And how do you know it's present value? Because he has this now. And he wants to put it in the bank and pay himself money from the bank over the next 20 years. So how much is each semi-annual payment? So here we are solving for R. Okay, so you can slow down the video, you can pause it at any time, but I'm just going to step through the solution. We're solving for R, so with your calculator, very, very carefully, make sure you get the same answer as me. And it turns out that he'll be able to pay himself this much money semi-annually. So twice a year, he can pay himself this much money. Okay, and that's pretty cool because here, I've written it for you here. 40 payments, right? 20 years, 2 payments each year. 40 payments of this much money is $744,000. And he only has $280,000, which means by investing this well, he's actually paying himself $744,000 over 20 years. Okay, last example. This person's buying a motorcycle for $500. He has $5,000. He has $1,000 saved for the down payment, Down payment is money that you pay the store right now because you have that in your pocket. So you pay the $100, the $1,000, but the balance you have to take out a loan from the bank. So he's giving the store $1,000, but now he has to borrow the rest, the $4,000 from the bank. Okay, he's going to repay the loan on a monthly basis over the next 2 years. This is the bank is charging 9% per annum compounded monthly. Remember that this is always going to match the monthly and the monthly, always going to match. Whenever you're compounding, that's also when you make the payment. What is the value of the monthly payment? So again, they're asking for R. Remember that down payment is not part of the loan because down payment you're able to give the store right away. So here's my solution. We know the present value of the loan. We know we owe $4,000. We don't know the R. Put all the information in and solve for the R. So that means that he has to make a payment of $182.74. Okay, and this is here the page number, so ignore that. Okay, that's how much he has to make. He has to make 24 payments of that, right? 12 payments a year for 2 years. When you figure out how much that is, he's actually paying $43.85.76 in monthly payments. He also put down a down payment of $1,000, so really he spent $53.85.76 on the motorcycle. But the motorcycle was only worth $5,000. So he really has been paying interest charges, $385.76 in interest charges, right? Because if he doesn't have the money to pay for it today, you know he's going to be paying more for it in order to pay over time. All right, so hopefully these examples will help you with future value and present value of annuities. Okay, good luck and thanks for watching.